We're going to talk about the remainder and factor theorems, and these both use synthetic division. Okay, so we did synthetic division on Friday. If we can do synthetic division, we can do this stuff. It's no big deal. So a little warm up here first. This says, given this function and the remainder when f of x is divided by x minus 9 is 1, so it gives me the remainder, then what is the value of k? Because notice I have a k in front of the x. So first time we've had a variable within a variable type of thing there. But if we know we're supposed to be using synthetic division, we can set it up just like we'd set up the rest of them. If I'm going to divide this by x minus 9, then what goes on the outside of my little box? 9. And then on the inside goes these coefficients. Now, this is a fourth degree. I want to make sure there's no missing terms. So I should have 5, 1, 2, 3, 4, 5. So I don't have to use a 0 in there. I'm good. My coefficients are 7, negative 63, 5, k, which I don't know, and then negative 80. Right? So then I go through my synthetic division. I drop down the 7. 9 times 7 is 63. Those zero out. And then, oh wait, I forgot something else. What do I know that I didn't know before? What's the other thing it tells me? It tells me the remainder. So I can go ahead and fill in my remainder. Should be 1. Okay. And then, so that's 0. 9 times 0 is 0. So that gives me 5. 9 times 5 is 45. Now, each time when I got to this step, I added these two to get my next thing. So I add these two, and I get k plus 45. Right? Then I do the same thing. The steps are the same. 9 times this value, so this is going to be 9 times k plus 45, and that's right where it goes. And then my remainder is 1. My goal here is to find k. Do you see an easy little equation you can set up? Because I'm supposed to add these two to get that 1, right? So I have negative 80 plus 9 times k plus 45 equals 1. Then I just got to solve that equation. I don't have to distribute that 9. I can, but I don't have to, so I'm not going to. I'm going to start by adding 80 to both sides, so I get 9 times k plus 45. That's equal to 81. I divide both sides by 9. That will give me k plus 45 equals 9. Then I subtract 45 from both sides, and k equals a negative what? 36. Good. Make sense? You see how it's still synthetic division? You just do what you know how to do, and you can handle that, no biggie. Okay? All right, so this is another part of the warm-up before we get to what we're trying to do here. So it says, consider this polynomial function. And the first, A just says divide it by x plus 4. So it's just, and we can use synthetic division again, so this is just straight up division. So on the outside, I put a negative 4. On the inside, I put 1, 1, negative 4, and 41. Okay. So then I bring down my 1. Negative 4 times 1 is negative 4. And that's negative 3. Negative 4 times negative 3 is a positive 12. That makes that 8. Negative 4 times 8 is a negative 32. And then that gives me 9 right there. Okay. So then to write my answer, because it just said divide, there's 3 terms, which means this first one's going to be x squared. So this is just x squared minus 3x plus 8 plus 9 over x plus 4. Okay, so that's exactly what we did on Friday. The B part of this says to evaluate the function when x is negative 4. So I want f of negative 4. So f of negative 4 would equal, I'm going to substitute it in, I'm going to have negative 4 cubed plus negative 4 squared minus 4 times negative 4 plus 41. Okay. So negative 4 cubed. First of all, will that number be positive or negative? Negative. Okay. So negative 4 times 4 is 16. 16 times 4 is 64. Good. So I got a negative 64 plus negative 4 squared is a positive 16. Then negative 4 times negative 4 is also a positive 16. And then I add 41. Okay. For me, in my brain, when I combine all those numbers, I don't just go from left to right. I would see that I know that 16 and 16 is 32. And I know that 32 is half of 64. So then that leaves me with a negative 32 plus 41. Right? So then f of negative 4 equals 9. So I know you know how to do synthetic division. I know you know how to evaluate functions. Now I want you to look at these two things that we just did, and what do you see is common in the answers? The 9. You see how f of negative 4 is 9, and my remainder here is 9? So that's what our remainder theorem is going to tell us we can do. You can substitute this in. These numbers weren't too terribly bad, but the bigger this number gets, the yuckier all this stuff gets, right? And even if that was a higher exponent. Where here, this was pretty smooth and kind of a piece of cake, right? And if I look just at the remainder, that's it. So we can use synthetic division to evaluate functions and not have to substitute it in like that. Okay, that's what the remainder theorem says. So it actually technically says, if a polynomial function f of x is divided by x minus c, then the remainder is f of c. So we call synthetic division because it's like fake division, that it's not really division, but it has the same result. So when you use synthetic division to evaluate, it's called synthetic substitution. Because you're not technically substituting, but it has the same effect. Okay. All right. Okay, so when I use the remainder theorem, I want the value of k, so it says the remainder of f of x is divided by, the remainder when f of x is divided by x plus 3 is negative 20, okay? So what that tells me is that since this is x plus 3, f of negative 3 equals negative 20. So I could figure this out by actually substituting into here and saying negative 20 equals, and I could substitute in negative 3's for all of this and then figure out k, but that's yucky. Since I know that, and I know that f of negative 3 is that remainder, that's what allows me to do the synthetic division to figure this out. So what goes on the outside here again is negative 3. My coefficients are 1, 8, 12, negative k, and negative 14. My remainder is negative 20. So why don't you try to figure out what k is here? So when you write this out, if you'd have just put minus instead of plus a -3, it would be fine either way. So I'm going to start by adding 14. So I get -3 times -k plus 9 equals a -6. Then -6 divided by -3, I'll get -k plus 9 equals a +2. So then -k equals -7. So k equals 7. What questions you got? We good on that? Yes, yes. Oh. So then the factor theorem, okay? The factor theorem says that given a polynomial, f of x, x minus c is a factor if and only if f of c equals 0. And if f of c equals 0, then what is your remainder when you divide? Isn't f of c equal to whatever your remainder is? So our remainder is 0. So what it's saying is if x plus 3 or whatever it is actually a factor of what you're dividing into, it should divide in there evenly, which should make sense because it would factor out. You with me? Okay. That's basically what that's saying. So this says, so here's another k1, and it says, given f of x equals this, and x minus 7 is a factor of f of x, then what is the value of k? So I can set this up. I know I'm going to divide, so 7 goes on the outside, and then on the inside, my coefficients here, and I've got 2, -7, -53, and k. But this time it didn't tell me what the remainder is. But if it is a factor, then that means that f of 7 has to equal 0. So my remainder is 0. Does that make sense to you? It has a mind of its own sometimes, I don't know. All right, so I'm going to drop down my 2. 7 times 2 is 14. So then this is a +7. 7 times 7 is 49. -4. Then this would be -28. So that means I have k minus 28 equals 0. So k equals 28. We good? All right, then y'all do number 5 on your own. Questions? If your work looked a little bit different, like I could have subtracted 8 instead of moving the other part, but in the end you got the same number, you're fine. Okay. Any questions at all? No? You good? You good?
Isn't that negative?
Oh, isn't what negative?
Like on the second level.
Oh, I added this whole part over here. That's why I did that, yeah. That's why I said I probably should have subtracted 8 and done it that way. You'll get the same answer in the end. It doesn't matter if you did it the other way. But I usually try and get everything positive that I can. But it works the same way because when you divide out, the signs would fix themselves, okay? We okay on all that? Okay, good deal. All right, so let's look at number 6. It says if you have this function and f of negative 5 equals 0, then find all of the zeros algebraically. Okay, so here's what this means. First of all, I'm going to still use synthetic division. So on the f of negative 5 equals 0, that means when I do my synthetic division with negative 5, my remainder is going to be 0. My coefficients that I put in here, I have a 3, a 5, a negative 42, a 40, and then a 0. Because remember, you have to have a placeholder for all of them. This is a 4th degree, which means there has to be 5 numbers in here. I'm missing that constant term. So that's why I had to put a placeholder for the 0. Okay, and then my remainder is 0. So let's go ahead and do this. And we also know that if I have f of negative 5 equals 0, that means that x equals negative 5. So that means that x plus 5 equals 0, and this is one of my factors. Okay, x plus 5 is a factor. All right, so I bring down this 3, negative 5 times 3, negative 15, then negative 10. Negative 5 times 10 is 50, and this gives me 8. Negative 5 times 8 is negative 40. Combine those and I get 0. Negative 5 times 0 is 0, and 0 plus 0 is 0, so I'm feeling good about that. So then I'm going to write out this part like my answer. So f of x equals, now there's 4 terms here, which means that this is an x cubed function. So this is 3x cubed minus 10x squared plus 8x. And then I don't have a constant term again. Now, I'm supposed to find all of my zeros. I know what one of them is. It's negative 5. But when I factor here, like this times x plus 5, if I multiply those two things together, do you understand how that should give me this right back since I divided the two? It's like if I take 6 divided by 3, I should get 2. So then 2 times 3 has to give me 6, that type of thing. So I have it kind of partially factored. I need to keep going with the factoring. In the part that I have left here, I have a GCF of x. So I'm going to factor that out. I'm going to factor out that x. That leaves me with 3x squared minus 10x plus 8. And then I still have this x plus 5 here. Then this part right here, I need to factor. So I'm going to go off to the side, and I have 3x squared minus 10x plus 8. I'm going to factor by grouping. So I do 3 times 8, that's 24. So I need two numbers that are going to multiply to give me a positive 24 and combine to give me a negative 10. What are my numbers? Good, negative 6 and negative 4. So that means when I split this, I get 3x squared minus 6x minus 4x plus 8. Then I factor by grouping. And out of this, I can factor out a 3x. That leaves me with x minus 2. Out of this, I can factor out a negative 4. That leaves me with x minus 2. So that gives me 3x minus 4 times x minus 2. And then that's what I write to replace this part right here. So I have f of x equals x times 3x minus 4 times x minus 2. And then I still have that x plus 5. So here, my synthetic division helped me factor, right? It helped me get started on my factoring there. So now I have 4 factors, which means I'm going to have 4 zeros. And so my actual zeros from least to greatest, let's see, this one's going to give me 0. This one gives me what? 4/3, good. This one gives me 2. This one gives me -5. And don't forget the 0, because that's the one that gets forgotten sometimes. So from least to greatest, I have -5, 0, 4/3, and 2. What questions do you have? We good? Awesome. Got to be able to factor, guys. Factor, factor, factor. And I think for the most part, y'all do okay on that. But we got a whole lot more factoring coming up. So